We have the question: a uniform chain of length L, mass M, is lying on a smooth table with 1/5 of its length hanging vertically from its edge. What work will be required to pull this hanging part on the table? So there is a table, and okay, we don't need to bother about both sides, and it is told that there is a chain lying on the table, and some part of it is hanging from the table, right? 1/5 approximately, we are drawing it such that 1/5 of the chain is hanging from the table. Okay, that is what is told. Now what work will be required to pull this hanging part on the table? Given data is length equals to L, mass equals to M. So what we have is mass per unit length of this chain is M by L, right? Mass per unit length of this chain. So we need to pull it, and we have to apply force in this direction, right? And it is acted upon by the force of gravity. G is there. So the force that is acting on the hanging part is equals to what? Let it be F, and F is equals to mass of that part, hanging part, M prime, times G, right? So mass of that hanging part is, let us denote it as this much length is X. Okay, so mass per unit length times X, that much mass is hanging. So the force acting on this part of this chain is M by L xg. Now we need to pull this chain, right? We need to pull this chain, and effectively our force should counteract this downward pull of this chain, right? So it must act upward, and we have to pull in this direction, and it must act in this direction. It must oppose this force of gravity. So what will be the work done by this force? So the work required to pull, say, dx a small bit of length from this hanging part to pull say dx length of the hanging part will be what? Elementary work done dw. This should be against this g, right? So negative, and negative of m by l x g is the force and dx. Okay, so what total work we need to do is we have to pull this whole chain up into the up on the table. So the total work should be when we have pulled all the chain back to the table, there will be no remaining chain hanging, right? Now how much is hanging? In the problem it is 1/5 of its length. So 1/5 of its length, so L by 5. When we take L by 5 to 0, that much distance our chain should move. So our dx should be from L by 5 to 0 minus m by L g x dx. And we take out all the constants from the integration sign and then do the integration. 5 0 x dx, that is an easy integration. It is equals to minus m L g x square by 2 L by 5 to 0. So what will be this? We can write, let us do all the steps to avoid any mistake. 0 minus this is x square by 2, so L square by how much it will be? 5 square 25 into 2, that is 50, right? So this is m by L g L square by 50, and we have, let us cancel L square and L. We have m g L by 50. So that much work will be required. So work required is what? W equals to m g L by 50 to pull the hanging part of the chain back to the table. And what is asked? That is what is asked in our question. What work will be required to pull the hanging part on the table. So 1/5 of the length was hanging, and after we pull the chain there should not be any part hanging. So 0 length hanging down the table will be 0. So L by 5 to 0 we integrate, and we get mgl by 50. So that is your answer.